Hi there. In this video, I'm going to address some questions that I've been getting from my Qimage users about the new Topaz AI Gigapixel resampling software, how that resampling compares to the resampling or interpolation in Qimage, and when to use something like the Gigapixel software. Well, first let's look at a simple image of 2 pixels, green on the right and black on the left. If we want to double the resolution of this simple 2-pixel image, we can make it 4 pixels wide, but then we have to decide what are the interpolated pixels. Those would be the 2 pixels that go in between. The most logical thing to do in this case would be to make a gradient from black to green and fill in the area in the center. This is basically how most mathematical interpolation methods work. They interpolate the data in between by predicting what could exist between known values. It gets more complicated than this when you have more data to work with, but this is the basic principle behind interpolation and how we get interpolated pixels. Since math-based interpolation methods don't analyze the subject matter in the image, you can think of math-based methods as being similar to stretching an image on a rubber sheet equally in all directions. As we'll see later, math-based methods can be more accurate than AI methods on average, but they can leave images looking a bit soft at extreme upsampling levels, as the stretching basically dilutes the information between known values. AI methods differ in that they try to fill in the blanks based on looking at a group of pixels and finding an object that most likely matches that pattern. It's like asking Google, what song is this? And by analyzing a short segment of notes in a certain order, in a certain rhythm, it can find the full song that belongs to that sequence. So some of my Qimage users have asked me about the new AI Gigapixel resampling method. And they ask questions like, what does that method offer beyond what Qimage offers for resampling? And should I use it on every photo? So I'm going to go into some detail here, and let's take a look at what the resampling tool does and when it should be used, in my opinion. So how do we evaluate interpolation methods? One way would be to take a sample image like this common test image found on the internet, downsample it by some extreme amount like 4x in both directions, and then take this downsampled copy and resample it back to the original size, and then check to see the result of that upsampling back to the original size compared to the original to see how close we get. So that's what we're going to do here. We've basically taken this original image, we've downsized it to 1/4 the resolution in the X and Y, which leaves the downsampled version 1/16 the overall area of the original. And at that size, it means that only 6% of the data from this image will contribute to the final resampled version. 94% of the pixels will be interpolated. So let's take a look at what happens when we don't interpolate. We'll zoom into this image to 100%, and we'll take a look at what it looks like when we just zoom in on the image. So with no interpolation, when we just zoom in to 400% to get our image to the same size as the original without interpolation, we can see lots of jaggies and basically blocks of multiple pixels where there used to be 1 pixel. So you start seeing things, if we lock these two together, you start seeing things like pixelization and jagged edges in areas like this, on diagonal lines, areas like this. So this is a non-interpolated image, and this is the reason that we want interpolation. We want to get rid of these jaggies and make the image look like a smooth photo again. One thing that I've done here is In this sample image, I've added my own piece of line art here. Let me show you what that is. It's basically just a raster image that you might get from a line drawing. It's a square rotated 45 degrees, a rectangle, and 3 lines at various angles. So here we're going to take a look at what the different resampling methods do, and a simple example like this can sometimes show what the methods are doing at their lowest level. Now we're going to take a look at what the Qimage output looks like with the Qimage fusion interpolation. And we'll look at the original versus the interpolated version. We'll lock these together, and we'll notice that the jaggies are no longer there. We no longer have blocks of pixels and jagged edges like here on these spheres. They're smooth now. Well, we notice that we've lost some sharpness. The edges aren't quite as sharp as they are in the original. You'll see that the baby's faces here look a little bit softer than the original. And the reason for that is we've added so many pixels here that are not from the original data that we don't have enough information to determine whether an edge should be this sharp or softer, like this edge. So the math works out to where it blends the data, which naturally makes it look a bit softer. But it has gotten rid of the jagged edges, and in a print held in your hand, it would look pretty good. Now let's back out of this and take a look at the original versus the AI Gigapixel interpolation. See what that does. Right away we can see that the Gigapixel version is quite a bit sharper. It's taken data and sharpened it, especially on hard edges. We can go down and look at the baby's faces and see that while they're not quite as sharp as the original, they're sharper than any math-driven interpolation method can be. But of course, anything comes with drawbacks. One of the drawbacks is that because we don't have enough data to determine which edges should really be this sharp, we get some data that really shouldn't be there. And I'll give you an example. In this baby's eye here, the eye looks normal in the original, but the interpolated version has a hard edge that looks like a reflection, and it looks like the Gigapixel method may have basically picked sort of a stock eye. It realized that it was an eye and put an eye in there, and it doesn't really belong with the face. It makes it look a little bit odd. Same with this eye here. These eyes have some hard lines on there that shouldn't be there. And there's some other drawbacks as well. You can see that the cloth here with the checkered pattern, the Gigapixel method has decided that those should be stripes. And it also does some smoothing. Even if you turn smoothing down to the lowest level, you can see here that there's a scale on this control patch chart, and it's smoothed over the scale so it's no longer visible here. It's basically removed it. And it's made some decisions here that don't necessarily go with the photo, such as this is obviously a chain here, and over here it looks like some sort of melted metal sculpture, and the gear teeth don't look correct here, don't look like gear teeth anymore. And interestingly, it takes these letters here and distorts them to the point where some of these letters are not recognizable anymore. They're sharp, but it's changed the pattern. And we also get some effects like that on this wheel up here on the top, on the sun wheel, where you can see that this is smooth and it's inserted some muddiness or modeling in between the spokes here. And if we go over to our baseline test, we can really see that over here on the right. Of course, we don't have that in the original because I added that at a later time. But you can see that it's taken the squares and rounded off a couple of the corners, added some sort of mud in between there, and I'm not sure why that is. Maybe it was trying to match that to some kind of photographic content. So maybe this method is not best for line art. There's a few other anomalies in here, like the 8 and the 6 on the calculator are no longer recognizable. So it's made some decisions, some creative decisions that don't quite match the original. And here we can see that the surface of this sphere is rough, and it smoothed it out quite a bit over here. It does a lot of data smoothing, even if you uncheck that box. In here, on this little spoke, you can see that the original is rough, and it has smoothed that out. It keeps the hard lines in it, but it smooths the rest of the low-level fine detail, smooths that out. So you can see some of the pros and cons of this method here. And we'll go and switch over to the Qimage version, compare that to the original. In some of the same places. And you can see that in the photo disk letters here, you can still make out most of the letters. They don't look like odd shapes anymore. The scale here, it's still visible that there is a scale there. Obviously, it's not going to be as sharp as the original because we don't have enough data to put that back together. But you can see that there is a scale there. This cloth, you can tell that it's more a spotted pattern and less of a striped pattern. We don't have the hard reflections in the eyes here that make them look strange. The surface here of the sphere and this area here is rougher, like it should be. And if we go over here and look at the calculator, the 8 and the 6, even though it's softer, it's still recognizable as an 8 or a 6. Your mind can put that together and recognize it. And most importantly, the control over here, again, there's no original here to compare it with, but we know what the original looked like. We have uniform smooth edges and no mud in between the different patterns here. So you can see some of the ins and outs with pros and cons with these methods. And honestly, if you get to the point where you have to upsample this much, then you're going to notice softness in the math-based interpolation like Qimage uses, and you're going to notice some strangeness in the patterns created by the Gigapixel method as well. So it's just picking one over the other. And at this level of interpolation, you probably are going to get a better looking photo out of the Gigapixel interpolation, just because it makes it sharper, and that's what your eyes are keying on. If we compare the Qimage version next to the Gigapixel version, we can see those various aspects here. You can see that the eye no longer looks strange here, but the image is softer on the Qimage version. Even the beads here. The beads are true to their original color, and you can tell that they're round here. Over on the Gigapixel side, they look like some sort of gems that are no longer round, and it's changed the color of them a bit. There's some sort of weird patterns in the clock here with a little bit of what I was calling mud in there. A little bit of that visible up here too. A little bit of muddiness in these colors here that didn't exist in the original. The chain looks more like a chain would look, and the gear teeth look like normal gear teeth in the Qimage version. Over on the Gigapixel side, it's sharpened them quite a bit, but it looks almost melted over here. And on this sun wheel, it's done some strange things on the Gigapixel side. There's mud in between the spokes here. This spoke is no longer continuous. It's decided to disconnect that from the side. So there's pros and cons to both versions here. And you have to just be aware of those. And like I said, honestly, if you print out a photo and your main complaint is it's too soft, then the Gigapixel method can account for that and can correct that. It can give you a sharp looking photo. But again, you have to realize that at this level of interpolation, we've upsampled so much that there's very few original pixels left. Almost this entire image has been interpolated. So if you're looking for a sharp print at sizes well beyond what you would normally print, then the Gigapixel thing really does an amazing job. And it is, in most cases, it does find reasonable data to put in the place of those missing pixels. Like a lot of these leaves here look sharper. They may not be true to the shape and placement of the original leaves, but they at least look sharp. So that's where this Gigapixel, the AI, comes into play. It allows you to get a sharp photo that may not necessarily be completely true to the original. And that gets me to my last point, which is for a photo printing application, you really want the print to be faithful to the original. You don't want anything creative going on. Leave that to the creative tools, which I consider the AI Gigapixel to be more of a creative tool that you use outside of photo printing when you need it, in cases where you have to have a really low res photo printed at larger sizes or things like that. If we take these images, an interesting fact is that if we look at the original versus the Gigapixel AI interpolation, and we do an arithmetic difference of the original versus the interpolated copy, we can take a look at the average error pixel by pixel. So if we look at every pixel in the image, the average error for the Gigapixel AI interpolation is 7.94%. Now if we do the same thing with the Qimage version, we can compare the original to the Qimage version and see what the error is on that. It was 7.94% for the Gigapixel interpolation, and it's 7.39% on the Qimage Fusion interpolation. So it's actually lower error rate on the Qimage version, even though the image looks a little bit softer. So I think the bottom line is you want to be faithful to your original photo, and you want what is going to your printer to accurately represent your original photo. And that shouldn't be a problem as long as you're within reason of your original pixel size. So if you're at 2x or less, you won't see much of a difference between even a regular bicubic resampling method versus the Gigapixel method. It's only when you start getting in the 3x, 4x, 5x, 6x range that you really start to see a difference in sharpness. And the reason that the Qimage version is actually more accurate to the original pixel by pixel is that it doesn't alter the colors as much or try to put data in there that it doesn't have enough information for. But that doesn't really matter in the end, because you want something that looks best to you. So if you prefer the sharper look of the Gigapixel, which would look super sharp in the final print output, then it's a good tool to have in your toolbox. And it does a really good job with that, even though it may not be quite as faithful to the original mathematically or data-wise. So I would say no to the people who have asked me, you shouldn't resample every image with the AI Gigapixel Resampler for two reasons. One is because you won't need it unless you go huge or you have really tight crops. And two, it's very GPU intensive. I have a GTX 1080, so I didn't really notice a really big problem. It took about 10 times longer to do the AI Gigapixel resampling, but 10 times is not that bad considering what it's doing and the calculations it's performing. But I've heard from some people that can't run the Gigapixel software because their graphics card is not powerful enough, or it takes 30 minutes or longer to resample one photo. Like I said, I haven't noticed that because I have a high-end graphics card, but that's something to consider too. You don't want to put that burden on yourself if you don't really need it. And a typical 24 megapixel photo can easily print at 30 by 20. That would be around 200 ppi. And even though the ideal is 300 or above, the difference between 200 and 300 is only 1.5x. So you're not going to see a huge difference between interpolation methods at normal print sizes and normal photo sizes. I would say use it sparingly and be aware of the limitations, what to look for. I probably, based on what I've seen, probably would not use it for line art, but it is definitely a tool that can take extreme upsampling when it's needed and make a usable print out of that where you could not before. So I hope this helps people in showing the differences between interpolation methods, what they're doing, when to use them, and the pros and cons of each. Thanks for watching.